Using integral calculus, we can determine the total change based on many other infinitely smaller changes. Assuming that one looked at, say, a rectangle with a width along the x-axis of 5 units and a height along the y-axis of 10 units, what would be the area of that rectangle? Well, that's not so hard, because it's the height times the width, or 5 times 10, which gives us 50 square units. We could also divide the rectangle into sections along the x-axis and sum up all the parts of the subsequent smaller rectangles. Okay, so now dividing our x-axis into 5 equal parts of 1 unit each, now the sum of all these rectangles would be 1 times 10 plus 1 times 10 plus 1 times 10 plus 1 times 10 plus 1 times 10. This gives us 50 square units again. Of course, you could continue the process and make the x-axis lengths smaller and smaller, and that basically is what integral calculus allows us to do. This, of course, is an easy example, since the function is a constant y equals 10. But what if the y-axis function is a parabola? Then you would have to take very small increments and sum them up to get the area under the curve. A parabola is y equals x squared. The integral becomes x cubed over 3. This would yield an area given by 5 times 5 times 5 over 3, if you get my drift.